This is number 28 from the 2013 Mock Contest number 2 Sprint Round. And this is one of my favorite problems that I wrote for these mock contests. And it asks for some base 10 numbers that when you write them in another base, they're listed as all ones and zeros. It turns out that the fact that we included base 2 should have been noticed to be irrelevant, because every number in base 2 is written as ones and zeros. So really all we're worried about is finding numbers written in with ones and zeros in base 3 and in base 5. If you try to work backwards, which means if you try to take a number like 64 and say, does that get written in with ones and zeros, you're not going to have a lot of luck on this problem. What you need to do is you need to consider what a number looks like in base 3 that has ones and zeros. Well, first off, we remember that the way we calculate the base 10 representation of a base 3 number is we look at how many of each of these we have. I'm going to go all the way, that working into 3 to the 6th. And so if we have all of these being ones, then that means we'd have 3 to the 6th plus 3 to the 5th plus 3 to the 4th plus 3 to the 3rd, 3 squared, 3 to the 1st, 3 to the 0. And any combination of adding those together is also going to be all ones and zeros. And so all we need to think about are these numbers. We'll start with 1. 3 to the 0, 1, 3, 9, 27, 81, 243, and 729. I don't need to go higher than that because we're just talking about 3-digit, or less than 1,000. And so any number that fits our criteria is going to be a sum of one of, or a certain number of these each one time. Same thing for base 5, except that you're going to have 1, 5, 25, 5 to the 2nd, 125, 5 to the 3rd, and 625, 5 to the 4th. So we just got to start looking at combinations and see where these match up. Well, since 1 plus 3 is 4, you're not going to be able to match up with something, using a 5. And then you have 1 plus 3 plus 9 is 13. Well, again, you haven't got to the 25 yet, so that's not going to be useful. You notice that 27 and 25 are pretty similar to each other, and so maybe this is going to work. Well, if we add 27 plus 3, we get 30, which is the same as 25 plus 5, and so 30 is written as a base 3 and a base 5 number using only ones and zeros, because you got a 27 and a 3, and so it would be 1 0 1 0, and then you've got a 25 and a 5, so it would be 1 1 0, base 5. Then you haven't used a 1, so you can add 1 to both of those, and so you get 31, and you're thinking, oh wow, this is a nice problem, I'm finding these pretty quickly. Well, it turns out that another one doesn't happen for quite a while. The next one to happen, because if you start looking at this, we've used a 25, so we try to use 125. That puts us at things between 125 and, since this is 31, and 156. Well, look at the 3s. There's no way to get to 156. If you add 81 plus 9 plus 27 plus 3 plus 1 together, you end up with 121, which is not 125. So we know that we can't have something in there. For the same reason, we can't have something using 243. So our last chance is to have something using 625 and 729. Well, if I'm going to use 625, then I've got to use 125 too, so now I've got 750. So I look to see if I can make a 21 with these. Well, I can't. But if I add a 27 to that 729, I get 756. And it turns out that I can get a 5 and a 1 to get 756. And so 756 works as well. And so that is written using just ones and zeros in both base 3 and base 5. It's pretty easy after this point to convince you there are no more. If you go through and play around with the number sum, but it's very simple to do that. If you try it in a couple different ways, you'll see that there's no way you can get any more numbers that use just ones and zeros. And so the answer is, adding all those together, 817.